Okay, so the first question here, it says, you know what, I actually don't have the directions pulled up, but basically, like, what is the complete factorization of this polynomial? So when we have four terms like this and it's a cubic function, so x cubed and then x squared and then x and then a number, I use the factor by grouping method. So I'm going to group the first two, group the last two, and take out a GCF of each group. So focus just on this first group. I kind of think to myself, what do they have in common, or what could I take out of both of them? Well, they both have an x squared. So I'm going to take out an x squared, and then in parentheses I'll write what's left over after I factor out an x squared. So the first term I would have x. The second term, if I take out an x squared, I just have 2. So x plus 2. Do the same thing for the second group. So here they have 4 in common, so I could factor out a 4 from both of them. And then if I do that, I have x plus 2, again, left over, okay? And what you'll see is that these right here are the same. So that's kind of like our common factor between the two groups. So x plus 2 is our common factor. And then the leftovers, x squared and a positive 4, or x squared plus 4, is the second factor, okay? Give me 1 second here. I just want to make sure that it doesn't go any further. It does go further. Okay, so then we want to completely factor, like using imaginary numbers as well. So x squared plus 4. We know that if that was x squared minus 4, we could break that into x plus 2 and x minus 2 because it's the difference of squares. With x squared plus 4, we can kind of do the same thing, except it's with imaginary numbers. So this just kind of stays x plus 2. And then we can split this into x plus 2i and x minus 2i. Okay, so x plus 2i and x minus 2i. So then off to the side over here, if I were to FOIL x plus 2i and x minus 2i, I would have x squared minus 2ix plus 2ix, so those cancel, and then minus 4i squared. We know that I squared is -1, so when I multiply -4 and -1, I end up with positive 4. That's why I can factor x squared plus 4 as x plus 2i and x minus 2i, okay? And so that's your final answer. That's the complete factorization of that problem. Okay, so then the next one, it says, which of the following are roots of the polynomial function? So this is something, I don't know exactly how Apex leads you to do this. I use a combination of our calculator, since that's a tool that we have, as well as like some, like to find the other roots, some algebra, okay? So what I'm gonna do, because you can't see my calculator screen, we're gonna use Desmos, so I'm gonna take that equation right there and I'm gonna enter it into Desmos. So I'd like to do this together so that you can see what I'm talking about here. So we're going to go to Desmos, the graphing calculator, and I'm going to plug that equation in or write it out. So x cubed is actually the first function, or the first part. So x cubed minus 7x squared plus 13x and then minus 6. And what we have, our Desmos, I really like Desmos because it just gives us those 3 roots or those 3 solutions like right off the bat, okay? And then I'm going to write those down, but I'm also going to make note of like the only one that's a rational number. So those other, the decimal ones are kind of weird decimals. The only one that's a rational number is 2. So I'm going to say x equals, that was 0.697, x equals 2, and x equals this one, 4.303. Okay, so this is kind of a note for later on. If you notice on Apex, it does not give you decimals as your answer. It gives you like the radical form. So I want to show you how to get what Desmos gives you. All right, so we're going to take the middle one there, that's a rational number, and we're going to do synthetic division with this root or with this solution. And that'll kind of prove that it's a solution, but it'll also help us get to our second ones, okay? Or our last two roots. So I'm going to take 2 is my root there. I'm going to take the coefficients of my equation here. So 1, -7, 13, and -6. And I'm going to do synthetic division, and I'll just kind of walk through this. So I bring down the 1, I'm going to multiply 2 times 1 is 2, and add my numbers down, -5. Then I repeat the process. Multiply 2 times -5 is -10. Add my numbers down, I get 3. 2 times 3 is 6. Add my numbers down, and this last number is our remainder, which is good. We know that it's a solution, so it should not have a remainder, which kind of proves to us that it's a solution. What I'm going to do next is I'm going to write this. So take these are the coefficients of like what's left over after I factor out a root of 2 or a factor of like x minus 2, okay? So since we started our original equation with x cubed, this is going to start 1 degree less than x cubed. So it's going to be 1x squared negative 5x, and then 3 is our number, okay? So 1x squared minus 5x plus 3, I'm going to set that equal to 0, and then I'm going to solve that equation. Now we know when we solve that equation, we're going to eventually get these two answers, but they're going to be in radical form. So if I look at this equation right here, I can tell it's not going to factor. There are no factors of 3 that add to give me -5. So then I'm going to use the quadratic formula. So I'm going to say x equals -b or opposite b, 5, plus or minus the square root of b squared, -5 squared, minus 4 times my a value is 1, times my c value is 3, all over 2a, 2 times 1. And then I use my handy calculator. I'm going to do what's under the square root. So this right here is our discriminant. I'm going to do that first. So I get x equals 5 plus or minus the square root of, so I'm going to plug in exactly like it looks. -5 squared minus 4 times 1 times 3, and I get 13. All over on the bottom here, I just 2 times 1, I do that, and I get 2, okay? And then those are technically my two solutions. Since I don't know the square root of 13, I'm going to leave it. So it's 5 plus the square root of 13 all over 2, and 5 minus the square root of 13 all over 2. If you were to actually solve that out, you're going to get right here, that decimal, and this decimal, okay? And that's it.